All right, hello everybody. Welcome to our free response question week 1 recap. Okay, this is meant to be watched after you've done the practice free response questions and after you've also seen the score of them, looked at the feedback, and took a look at the right answers. Okay, so if you haven't done all that yet, hit pause, go back and do that. Okay, this is meant to be a recap after you've kind of done the best you can with the problem. Okay, now why are we recapping after the problems instead of reviewing ahead of time? Well, the big reason is we haven't done really a lot of coding. We haven't looked at a lot of stuff for pretty much a month once you've added all our breaks together. So if you remember how to do something at this point a month later, I'm not worried about you forgetting it for the exam in 4 weeks. Okay, that's in your long-term memory. You're good. You got that stuff. Whereas if we reviewed on Monday and then you did these problems on Tuesday, I'm not sure that that's in your long-term memory. I don't know if that's accurate as far as what you really know. Okay, so I want to do a recap because I'm really going to get to see what you know. Also, I want to see what we need to actually review and talk about. So for example, with this set of questions, there's 2 things that we talked about the first week of class. One was modulus. Okay, one was casting. You guys all got the modulus part right. We don't need to review that, but we did terrible with the casting part, so we'll spend more time reviewing that casting and just mention the mod real quick. Okay, so that's why we're recapping instead of reviewing. It's going to give us a better idea of what we actually know and what we need to review. Okay, this video will be a little longer than the other ones I make just because we're going to talk a little bit more about a general breakdown of the problems, okay, the type of problems you're going to see. Then we'll also go through the specific problems. We'll talk about kind of taking notes, making a cheat sheet here. Now, depending on how you did, if you didn't do so well with those problems, there might be a lot more. Pause the video, take some notes, take a look at how you did. If you cruise through those problems, if you got most of them right, okay, maybe you're sitting back, relaxing, let the video play out, maybe get a little bit from it. Either way, watch it, but depending on how those problems went for you, there might be a little more work here. Let's start off by reminding you the type of problems we're dealing with. Okay, in the normal AP exam, there's 4 different types of problems you can expect. Okay, for us, we've got the shortened exam, so we will not have writing classes. We will not have 2D arrays. You're going to get 2 questions from the categories of methods and control structures and array/array lists. Now, there is overlap between these different categories. If you can do one, you can really do stuff in all of them. Okay, but those are kind of the 2 types of questions we're going to focus on. That's what we're going to spend our time with these next few weeks here. Okay, the first question we gave you was a methods and control structures question. What does that mean? What does that deal with? Okay, well, there's kind of 2 bullets to it in the course description. Okay, write a program code to create objects of a class and call methods. That's the methods part of it. So basically what could happen is we only had 1 class in this example, but a lot of times there's 2 different classes. One class creates objects from the other class. And then more often than not with the 2 classes, one class calls methods from the other class. Okay, or like we saw in this part, you're writing methods for an individual class, and in a lot of cases what's going to happen is part B, the second method you write, calls part A, the first method. Part C calls part, that should say B. There we go, now it does. But kind of a hierarchy of different methods calling each other, and that's the big thing this first example looked at, was writing methods that call other methods. We'll talk about kind of the implications of doing problems with those. Okay, the other thing that this type of problem is going to focus on is writing program code to satisfy methods specifications using kind of 1 of 3 different things. Expressions, so as in plus, minus, times, divide, the mod, the casting. We'll get into random numbers. We'll get into some other stuff as we go through this review. Okay, but a lot of times there's calculations involved. Conditionals, you can for sure expect some type of if, else, if. Maybe it's even more than that. Okay, or it could be written with compound Boolean expressions, as in ands and ors. Okay, and then last part, iterative statements, in other words, loops. Okay, you need to be able to do for loops and while loops. You need to be comfortable with both of those, okay, for this type of problem. Okay, FRQ number 1 will for sure have each of those 3 bullet points in there. Okay, so let's talk about that first problem. I'd highly recommend here that if you can get things on 2 screens or split screens, definitely do that. Go into Moodle and pull that problem up so you can see the code for it, the descriptions, and also what you wrote out there. Okay, so pause the video, take a minute, and pull that up if you need to. I'll have some kind of summaries of what that question was about, but you definitely want to have that entire thing with you as you're going through here. Okay, first question dealt with the hailstone sequence. That's some type of mathematical sequence. If there's a math-focused question in the exam, it's going to be this FRQ number 1 here. Okay, and basically the way we make this sequence is a pretty simple pattern. N equals 1 will be the last term of the sequence always. That's when it terminates. If it's even, we'll divide by 2. If it's odd, we'll multiply by 3 and add 1. So here's an example of this. Okay, times 3 plus 1, divide by 2, divide by 2, divide by 2, until we get to the 1. There's a hailstone sequence. All right, then we have the hailstone class here. And the class doesn't really give us much. It just tells us the 3 different methods we're going to be writing. Okay, one to find the length, one to decide if it is a long sequence, then also to decide if it's the proportion of long sequences given an n. Okay, so really nothing else stored in here. We're just writing methods for this class. Okay, part A, we're writing the hailstone length method. Okay, the length of hailstone sequence is the number of terms it contains. So how many numbers are in that sequence? Okay, we want to write the method which returns the length of the hailstone sequence starting with n, n's our parameter. Let's go ahead and do that. As far as typing things in, I don't think you ever need to write in the method header. That's going to be given you in the problem. If you feel better about it, you can, but you don't need to waste your time with that. That'll be there. Okay, so for a length, the first thing we need to do is have something to actually count what that length is. Okay, and now one spot some students miss this on is they started with count equals 0. I can't do that unless you adjust at the end, which I did have a student catch it, but I'm going to start with count equals 1. And the reason for that is let's say I plug in an n equals 1 to this method. I still want its length to be 1, not 0, even if my loops don't run. Okay, so we've got to start off with length 1. Okay, and then what we need to do is continually find the next term in the sequence and adjust what that term is. Okay, that's going to involve a loop. I take that back. I'm going to do one thing before that. Now, a habit I like to get into is to put my return statement at the beginning as I'm writing the method. Okay, as I've scored myself, the biggest thing I've lost points for is just a silly thing. I'm supposed to return something. I calculate it. I forget to return it. So I'm going to put that right at the end of the method right away in the beginning here. I forgot I was going to do that. Okay, if that doesn't help you, that's fine. It helps me. That's why I'm going to do that. Okay, so that's what I'm looking to return is that count when it's all said and done. Okay, then what I need to do is loop through here. Now, the question is, should I be using a while loop or a for loop? Now, with this sequence going into it, I'm not sure how long it's going to be. I'm not sure how many times I'm going to need to loop. Therefore, I'm going to use a while loop. Okay, you use while loops when you're not sure ahead of time how many times you're going to go. For loops are predetermined how many times they will loop. Okay, now a few students, rather than n greater than 0, did n not equal to 1. Okay, so loop while n not is equal to 1. That's fine also, but I'm going to go with the loop while n is greater than 1. Same difference. And then we have our conditional part. Again, a part folks did well with. Okay, we have 2 different rules depending on if n is even or odd. If I want to determine even, we'll say n mod 2 equals 0. Okay, remember modulus gives us the remainder when we divide that by that number. So if the remainder is 0, we know it's divisible. Okay, therefore we'll apply the even rule, or else we'll apply the odd rule. Now we could obviously flip this around, mix this conditional up a little bit, okay, but it's simple if-else. And then each time we go through the loop, we need to add to the count because we're going to the next sequence or adding to the length. Some students put that count plus within both of these parts of the conditions, or we could have it after the conditional is done. Either way, you just need to count as you go. Okay, so that's it for that one. Pretty straightforward. Yep, I think that's all I want to say with that. Okay, part B, we're writing the is long sequence. Okay, so hailstone is considered long if its length is greater than its starting value. Okay, so in the example we looked at, the starting value was 5. I think its length was 6. We'd say that's a long sequence. Okay, write the method is long, okay, which returns true if the hailstone sequence starting with n is considered long and returns false otherwise. So in other words, if its length is greater than the n you plug in. Now, one detail of this one, it says you must use hailstone length appropriately. Okay, so to get full credit, I have to use that method that I just wrote. Now, with that said, let's say you have no clue how part A works, you leave it blank even. You can still get full credit for this question if you call the method properly, even though in real programming there's no way in heck that's going to work. Okay, each of these different parts are scored individually, scored separately. So again, even if the previous part of your program you know it's not going to work, you can still pretend like it does and call it in the next part. Okay, and also pay attention to that. It'll say that specifically. If you're supposed to call a method, you have to make sure you call it. And it's going to save you, extra code to write as well. All right, so let's go through that method. This one's pretty simple. I think there's only a 2-pointer. Now, a couple ways we could write it. Right off the bat, we could just return hailstone length of n greater than n and be done with it. Okay, that's going to return when I have this greater than symbol here. It's going to turn this expression into a true-false statement, and it's going to return true if that statement is true, false if it's not false. Okay, that's the most compact way to write it. I don't like it. I don't like writing stuff like that. So let's do it the way most students did it. Okay, they turned it into a conditional. So if hailstone length of n is greater than n, we'll return true, or else we'll return false. Okay, I think you're going to do a better job if you write them out a little bit more than that, rather than just having a single return. I'm more comfortable with that. If you like the other way, go ahead and do it that way. Okay, other way I saw some students write it is they actually defined a Boolean ahead of time, use the conditional to assign that Boolean, and then return the Boolean when it's all said and done. That works as well. Obviously a little more code to write, but if you have the idea, if you have kind of the big thing, this Boolean condition here figured out, it's really not going to matter if you spend an extra 30 seconds typing up the rest of the conditional. Okay, so we showed you a few different ways this will work. Whatever you're most comfortable with, go ahead. These would all give you the same results. Okay, really no huge advantage, especially even time-wise, for any one of them. All right, the last part of this question, part C, is doing the prop long method. Okay, the method prop long returns the proportion of long hailstone sequences starting with values between 1 and n inclusive. When you see inclusive, that just means include the n's, include the 1, include the n. Okay, write the prop long method. You must, I think that's supposed to say, use is long sequence. So again, each of these questions build off each other. Part B, use the method from part A. Part C, use the method from part B. Again, even if part A doesn't work, you can still use it and get full credit in this part. Okay, if you call it correctly, if you use the notation for calling it correctly. All right, this is going to be the bigger method, or the bigger part of this question. I think I forgot to mention, first part, part A, is worth 3 points. Second part was 2 points. This one will be 4 points, so the bigger of the three. Now going in, you're not going to be able to tell which one's bigger. It's not going to give you a point breakdown, so you don't know what part to focus your time on. You might be able to tell going in which ones are the important ones, but you're not going to know that. All right, so basically what we need to do is count up how many long sequences we have from 1 to n with that n plugged in there. Okay, so we're going to need a count. Okay, I'll say int count equals 0. And then what we've got to do is loop from 1 up to n and figure out, is each of those numbers, does it give us a long sequence or not? Okay, now I did see some students make a variation of this mistake here. A lot of students started their loop at I equals 0 and or didn't go high enough. They didn't go to n equals n to equal to n. They stayed strictly less than n. Okay, this is a pretty simple loop, but I think the habit we're probably in from looping through so many arrays is always just going from 0 to less than the length. Okay, so do pay attention to that. Typically, this question doesn't deal with an array. So the loop isn't going to go from 0 to less than length. It'll have some other criteria to it. Okay, so it's something to watch for. Again, we typically loop through arrays for the last couple of months. So just make sure you're not making silly mistakes because you're just in those habits, 0 to less than length. Okay, with that also, I suppose we could also do a while loop for this. I did have one student do that, and the way they did made a ton of sense. But since I know exactly how many times I want to loop here for n equals 1 and stopping, sorry, when I equals 1 and stopping when I is n, it probably is easier to use a for loop. Okay, as we go through, what we can do is we can say if is long sequence I. So in other words, is a sequence starting with the ith value, is it long or not? Okay, that's the big part of the conditional here. Now some folks, a lot of folks actually wrote it like this: is long sequence I equals true. The two of these mean the exact same thing. Whatever you're more comfortable with. Okay, I like that because it's a little bit shorter. Okay, if it is, we'll add to our count. That's all we're doing through the loop. We're going through each of those kind of starting values for the sequence, determining if that sequence is long, counting it up as we go. And then here's the biggest spot folks lost credit for this entire week. Okay, casting. We'll talk about this more specifically in a few minutes here. I want to return a proportion of the count of long sequences divided by the total sequences, so just the n. Now, since count is an int and n is an int, we're passing in an int, we define that an int, I do need to cast this as a double to actually get a double returned. Okay, double is my return type here. Okay, I did have a few students make their count a double, which took care of it as well. But like I said, the biggest thing we missed on here is something simple. Again, something we've been doing since week 1 of class is casting our ints as doubles, okay, before we try to return a double or before we try to define a double. Now, so that leads into the notes on this question. I'm going to call it a cheat sheet. It's open notes this year around. You know, you have the formula sheet we already gave you, but there's nothing wrong with adding some more things, kind of having a bigger reference packet than just that one page. Okay, so I'm going to say cheat sheet because what I'm hoping to do with this is you take some notes, especially if it's stuff you missed first time around. You're going to want to reorganize it later as far as what you think you want to have written down for a test, what you don't want. You don't want too much to be going through on the day of the actual test. But here's kind of the notes part that you can eventually turn into a cheat sheet for using on that test. First thing I want to talk about is casting. And the reason we need to talk about that is because integer operations, when I perform operations with only integers, okay, it results in an integer value always. Okay, that isn't a big deal except for when we get to division. So for example, let's say I have int x equals 5 and y equals 2. And if I want to print out 5 divided by 2, well, that's 2.5. But since this is integer division, that's going to print out a 2. Okay, the decimals we'd say are truncated. They are cut off. It's not rounded. Notice we didn't round to 3. We just cut the decimals off. We threw them away and only worried about the integer parts. Okay, we saw a lot of situations through the semester where that was nice to do. It's nice to do things that way. Okay, but in this case, that's not what we're looking for. What we need are double operations. Okay, if an operation contains at least one double, the result will be a double. Okay, so what we can do then is we can cast. Okay, casting temporarily changes the value, the type of a value. Okay, so here we're going to cast as a double. Same idea. If we have 5 and 2 and I want to assign that to a double, in this case we'll print it out. I'm going to move my face here. Hopefully it's gone now. If I go double, if I cast the x as a double, if I temporarily change it to a double, okay, a 5.0 instead of a 5, and do that division, this is going to print 2.5 for me. I could also go x divided by double y. I could change the y to a double. So a 2.0, that would print the 2.5. What I can't do, though, is I can't cast the entire expression as a double. If I have the expression inside the parentheses, it's going to do what's inside there first, x divided by y. That's integer division. That gives us a 2. All the casting to a double will do in this case is add the 0.0 to it. That way will not work. Okay, either of these first two ways would work. I suppose I could have also put on here both of them being cast as a double. That gets you the same result. Okay, I can't cast at the end, though. I need to cast before I do that integer division. Okay, the other kind of big topic I want to put in your notes from this first problem is while loop versus for loops. Okay, what I have here are a while loop and a for loop that does the exact same thing. Okay, they're both going to print off the first 100 letters, or 100 numbers. I suppose 0 to 99. Yeah, we'll call those the first 100. Okay, so you can use them interchangeably in a lot of different cases. Let's make explicit real quick the difference between the two. Okay, we'll say that while loops always work and for loops don't always work. Technically, you could force them to work with some adjustments on the eyes. By the time you're doing that, you pretty much have a while loop anyways. Okay, so when in doubt, if you're not sure which one will work, we'll say the while loop is always going to work for you. Okay, when to use each one? I'll get my face out of the way here again. Okay, use a for loop when you know how many times the loop will run. Okay, so even if that number of times is going to be a variable like an n in the last case, if I know that I want my loop to run n times, it's probably easiest to use a for loop. If you don't know how many times that loop's going to run going into the problem, like in the case of part A, where that sequence was going to be doing different things every single time, that's when you use a while loop, when things are going to be adjusting as you go. Okay, again, you can use a while loop in either case, but if I know how many times things are going to run, that's where I want to use my for loop. All right, let's get into the free response question number 3. We'll still call it number 3, even though it's the second one. Okay, the array/array list question. What is this going to deal with? Okay, basically write program code to create, transverse, and manipulate elements in a 1D array or an array list of objects. Okay, so it could have one or the other, could have both. For the last 6 or 7 years, though, it's always had an array list to it. We'll study both of them, but you're probably going to see an array list. Usually this type of problem involves 2 classes. One for a simple object, okay, that just stores a few pieces of information, and then the other class where you write the methods, basically that's going to be an array or an array list of those objects. Okay, and like I said, it can mix array and array lists. We didn't really see that with this question. We'll take a look at one like that in the next few weeks, just to make sure we're not confusing the two. Okay, this problem dealt with the product review/review collector class. Okay, I don't think I meant to have this stuff here. Oh well, the product review class is used to represent a single product review. Okay, so product review consists of the product's name and then a review for it. And we have that class here. Okay, this class, a product review object, will store a name as a string and a review as a string. Constructor just sets those, and then we can return both the name with the get name and the review with the get review. Okay, so again, an example of a real simple class that we're then going to make an array of. And then there's the review collector class, which is just used to represent a collection of reviews to be analyzed. And again, this is actually pretty simple. This class holds 2 different arrays. One array of product review objects. So again, this class holds a list of objects from the previous class, and then a second array that just holds strings for the names. Okay, again, we've got a constructor, which all it does is it instantiates those arrays, makes them active, and then we're going to write 2 methods, an add review method and a get number of good reviews methods. Okay, first up, write the add review method, which takes a single product review object. So we're going to plug a product review object in as a parameter for this one, and then does the following. The product review object is added to the review list instance variable. That's my list that holds the product reviews. And then the product review name from the product review object is added to the product list instance variable if the product name is not already found in the product list. Okay, so to sum that up, what's happening is we're going to plug a product review object into this method. We're going to add that review to the review list, and then if its name isn't already in product name, we're going to add the name to it. Okay, so in that product list, there will be no repeat names. Okay, let's go ahead and look at that code here. First thing, the simple part is just adding the product review to the review list. Okay, and remember, with an array list, we just use the add method. So we have the review list, we'll add the product review we're plugging in. Okay, that's worth a point right there. And then what we want to do is we need to go through the product list, okay, the list of names, and check to see if this product name is already in it. If not, we'll add it. If so, we'll skip and we won't do anything else with this method. Okay, so first thing I'm going to do is just to make things so I don't have crazy code going off to the right, is I'm going to store the product name, okay, in a string called prod name. Okay, so prod review, the one we're plugging in, dot get name. So we're calling methods from that from that other class. You don't need to do this step, but it's going to make my code look a little bit cleaner. Okay, and then the other thing I'm going to do, anytime I'm searching and I want to do something depending on whether I find it, I want to make a flag variable. I'm going to say Boolean found equals false. Let's assume right off the bat that that name isn't already in the list. And then what I'll do is I'll loop through my list. Okay, so for int I equals 0 to I less than the product list dot size. And each time through with each new string in the product list, I'll check and see if the product list dot get I, so in other words, get the name, get the string in that product list, dot equals the prod name variable I just found. And if it is, I'll assign that found to true, and I know not to add that to the list if that variable is true. Okay? What makes this tricky? The big thing to pay attention to is we have two different arrays, and you need to make sure you're looping through the right one. We want the arrays of just the strings, of just the names. And then also what makes this tricky is this kind of connected method calls product list dot get I that gets the string dot equals prod name. Okay, I guess the other way we could go through this is with an enhanced for loop. We could also say for each string name in product list, if name dot equals the product name, we can set found to true. These two sections of code do the same thing. I prefer the run on the right. I think with the answers I gave you, what was on the left, because I figured that's what most students would do. That's what most students did. I'd encourage you as you're going through here, think about, try to take advantage of those enhanced for loops. No issue if you don't. They're never going to say you have to write an advanced for loop in a free response question. Okay, but make sure you're comfortable with both, because I'd say this is a case where this makes life a lot easier. Okay, so I've gone through the entire list. I've determined if the product name is in it. Okay, and then what we can do is we can say if not found, so in other words, if found's not true, we can just add that name to the product list. Okay, you could also say if found equals false, okay, or just not found, add the name. All right, next up, part B, write the get num good reviews method, which returns the number of good reviews for a given product name. Okay, a review is considered good if it contains the string best. Now, the actual problem had some stipulations about capitals. It said just lowercase. So yeah, we're just looking at lowercase here. And yeah, basically what I'm going to do is I'm going to plug a string product name in, and we're going to figure out how many good reviews we have in that review list. Okay, so let's go ahead and do that. I'm counting how many good reviews I have, so I need a variable for that right off the bat, an int. And like I said, if I'm going to be returning something, I like to put that at the end of my code, at the bottom of my sheet right away, just so I don't forget to do that. That helps me write. Okay, if it helps you, doesn't help you, whatever, throw it off if it doesn't help you. And then what I need to do is I need to loop through my review list. Okay, so for loop, int I equals 0 to I is less than review list dot size. We need to go through the whole thing. And what we need to do is we need to check if what's in the review list at I, so get I, and then what's in the review list is a product review, which is an object with both a name and a review. I'm going to look at the name first, dot get name, and I want to see if that's equal to this product name we're plugging in. Okay, so first thing I need to do is for each review check and see if the name matches up. And then what I can do is once I know the name matches up, so if the name matches, then I'll run this inner code if review list.getI.get the review. So if the review of that product review object, basically here, we'll talk about this in a second, contains the string best, we'll add to our number of good reviews. Okay, probably easiest to write this as a nested set of conditionals. You could write it as a compound conditional with an and. I think no matter how you type it, it's going to be going off the screen, so probably easiest to do this as a set of conditionals. Now, the biggest thing I saw students struggle with this one, this was the kind of number 2 error we made, was incorrectly using this index of. The way to determine if a substring's in a string is going to be use the index of method. And this returns where that best shows up in the string. And if it's not in it, it's going to give us a -1. Okay, so by doing this dot index of best greater than -1, we're going to know if it's in the string or not. Okay, biggest thing students miss with this one is this greater than -1 part. Okay, this doesn't return a Boolean. It doesn't return a true false. It returns an int, the actual index. That's why you always need to use this greater than -1. Okay, with this when you're using this method to check. From there, once we've looped, it's just a matter of returning the number of good reviews, which we have. Okay, again, I'd highly recommend with this one, use that enhanced for loop. This makes life a lot easier. Okay, so for each product review P in that review list, if the product review P's name is equal to product name, and then if the review, same thing here, index of best is greater than -1, then we'll add. Whoops. Okay, so again, same thing, these codes accomplish the same thing, but hopefully as you're kind of seeing these next to each other, you see how one makes life easier than the other one. Okay, the one thing I do want to talk about here then with this one, we'll hide my face here, is that index of. Okay, so if I take a string and go index of a substring, it returns the first index that the substring occurs in the string, and a -1 if it does not occur. So really the biggest spot we've used this in class is to determine whether or not a substring is within a string. So for example, if my string s is computer and I go s.index of put, okay, well put happens at the 0, 1, 2, 3rd index, so this would return a 3. If I go s.index of ABC, ABC is not within computer, so I'd get the -1 here. And then again, the big thing we missed is set greater than -1 to check if a substring's in a string. So as an again, if I have my computer here and I go s.index of put is greater than -1, that would return true. That would make the conditional it's in true, okay, because that put is within computer. Whereas if I had s.index of ABC is greater than -1, that would return a -1 for me. I'm sorry, this part would return the -1. Okay, making this statement false. Okay, so again, if that was in conditional, I get the negative there. All right, so there you go. There's a breakdown of the first week's worth of problems. Okay, we'll make shorter video for the rest of the weeks, a little bit less to talk about, kind of more focused on the specific problems there. If you did well with these questions, you're probably good now. If you struggled, if you still don't get some stuff, maybe you go back and watch part of this. Okay, again, look at how my explanations, my answers compare to yours, what you need to do to fix them. And then if you still have questions on how things work, make sure you send an email. Make sure you're meeting me on my office hours. Okay, yes, you're doing the questions. You're taking the time to write them out and see how you did. But you definitely want to take some time to use the feedback, figure things out, study the stuff you don't know how to do. Okay, and that's the whole point of this here. All right, we'll see you folks later. We'll see you next week.